Hello, my name is Angelica Coriano. I'm a student at Valencia College in the Bachelor's for Engineering Technology degree. This is my submission for lab number 2 for Digital Systems 2114C. This video submission will include parts 1, 2, and 3 of lab number 2, with timestamps being posted in the description box. I'm going to begin with part 1 right now. Beginning with part number 1, first I'm going to start with the circuit. So part 1 of this lab includes building a circuit with an AND gate connected to an inverter, which is a NOT gate. I'm going to show the picture right here. So we have inputs A and B going to an AND gate and then connecting to a NOT gate. This is my circuit right here, so I'm going to focus in on the chips themselves. This is a 74 LS08, which is an AND gate chip, and this is a 7404, which is a NOT gate chip. I'm going to explain a little bit more about how these chips are connected. So pins 1 and 2 are connected to switch 1 and 2. All the wires here are long or green. So I'm going to just wiggle them a little bit. So we have this wire, which is input A, connected to switch 1. So I have here pin number 2. This is pin 2 right over here. Pin 2 is input B, which is connected to switch number 2, which is right here. I'm wiggling it just because they're all green. So that's input B of the AND gate. Then we have the output, which is in this case Z. Yes, output Z of the AND gate, which is going to the input, which is pin number 1. Focus in a little bit more. Of the NOT gate, the inverter. That output is also connected here to an LED. It's kind of hard to see. Let me try to move this wire right here a little bit. But yes, so, I tried. The output of the AND gate is connected to this green wire, which goes to LED number 1. It's supposed to be number 1. I'm going to switch them right now. Number 1. So 1 and 2. Making sure that it's still connected here. So that output of the AND gate, which is output Z, is connected by this white wire and then by this green wire to LED number 1. Right. So it has 2 connections there for that output. And then in the NOT gate, the output, which is pin number 2, is jumped to this green wire right over here in this row. And that wire goes to LED number 2, which that output is W. So output Z, which is the AND gate, is LED number 1. And output W, which is after it comes out of the inverter, is LED number 2. Both these chips have pin 14 connected to the positive terminal, which I have on the 5-volt VCC. And then both pin 7s on the chips, which is the negative or the ground, are connected to this ground I have right here. And that is my circuit. I'm going to start going through the truth table for my circuit. I'm going to turn it on. Sorry. So that is my circuit on. Oh, I guess my pins aren't all off. So one already lit up. So here we have inputs A, which is 1, and B being 0, 0, 0. And the output Z, which is LED number 1, is 0. And LED number 2, which is W, is 1. So now, the next one is 0, 1. So 0, 1. So LED number 1, which is output Z, is 0. And LED number 2, which is W, is 1. Make sure that LED is connected, just in case. Yes, we're connected. Alrighty. The third input is 1, 0. So LED number 1, 1. LED number 2, 0. Oh, it works. So it's going through. Output Z is 0 again. Output W is 1. Alrighty. Now, the last one is 1, 1. So 1, 1. In this case, output Z is 1, which is the AND gate, and output W is 0, which is the inverter. So LED number 1, which is output Z, is 1. LED number 2, which is output W, is 0. And that is my truth table for part 1. So now beginning with part 2, you'll be building a circuit with a NAND gate connected to an LED. I'm going to show you the circuit right now. This is the diagram, which has inputs A and B going into the NAND gate, and the output is Z. Let me show you my circuit now. For this one, we use chip 74LS00, so 7400. Can't really see the numbers here. But anyways, pin 1, which is input A, refocus please. Pin 1, which is input A, is connected to switch number 1. Pin 2, which is input B, is connected to switch number 2. The output, which is pin 3, has been jumped to this row with this wire connecting to LED number 1. Yet again, pin number 14 is connected to positive, which is at this 5-volt VCC. And pin 14 for this chip, which is the negative, is connected to ground. It's connected to the ground I have right here. I'm now going to be going through the truth table here that we have for the NAND gate, which has my inputs A and B, with the output Z be connected to LED 1. Input A being switch 1 and input B being switch 2 on my circuit. I'm going to turn on again my kit. So, for the first one, we have inputs A and B being both 0, 0. So, still confirming here, 0, 0. And I get a 1. So, that is a 1. Moving down to the next one, we have 0, 1. With input A being 0 and input B being 1. So 0, 1. The LED is lit, so it's still 1. Moving down, we have 1, 0 with input A being 1 and input B being 0. So 1, 0. I just switched them there. 1, 0. The LED is lit, so it is a 1. Moving down, we have inputs A and B both being 1. So we have 1, 1, and the LED is off. So it is a 0. So that is my output Z for the data inputs. I'm also going to turn off the kit right now and perform the second part, which involves connecting input B to the VCC and seeing how this gate behaves. So now we have the second part, which says to remove input B from the switch and connect it to VCC and monitor the output. So here, I no longer have switch 2 connected to anything. The kit is off, so it wasn't going to do anything. Input B, which is pin 2 here, it just popped out, is now connected to the 5-volt VCC. So pin 2 is now consistently 1. Since it's connected to the 5-volt VCC, and I'm going to be toggling switch 1, which is input A, back and forth to see how this circuit behaves. So I'm going to turn on my kit. So, with input A being a 0, the LED is lit, and with it being a 1, which is a high, that's my on, it is a 0. So when input B is connected to the 5-volt VCC, and it's only me toggling A, it acts like an inverter. Because when I put 0, and it's only one input, one switch that I'm toggling, when I have a 0, it inverts it to a 1. And when I have a 1, it makes it a 0, instead of making it a 1 or a 0 as an AND gate would. Okay, so beginning now with part number 3, which is a circuit connected to a NOR gate. With a NOR gate, I'm going to show now the circuit here. So inputs A and B are going through a NOR gate with the output being Z. I'm going to show my chip right here. I have chip 74LSO2 connected here, which when you look at the pin diagram, it's a little bit backwards. So input A, focus, which is switch 1, is connected to pin 2, because that's input A. Input B, which is switch 2, is connected to pin 3, because that is actually input 2. And the output is pin 1, which is connected to an LED number 1, with pin 14 connected to positive, VCC, and pin 7 connected to ground. So beginning with part 3, going through table 2-3, the truth table, we're going to turn on the lab kit. The first data input is 0, 0. So I have 0, 0. I get a 1. Alrighty. Now next is 0, 1. 0, 1. I get a 0. After that, I have a 1, 0. So 1 and then 0. I get a 0. And last, I get 1, 1. Focusing a little bit. So 0, 0, 0, 1, 1, 0. Now 1, 1. And I get a 0. So that is going to be the truth table for the NOR gate. I'm going to pause and rearrange my circuit to do the second part, which involves connecting input B to ground and seeing how the circuit behaves. So now beginning with the second part, which says to remove input B from the switch and connect it to ground and observe output Z. I'm going to show here now my power is on. Focus in. Switch 1 is still connected to input A. Output, pin 1, with pin 2, my bad. Output A, which is switch 1, is still connected to pin 2. Output Z, which is a complete output, which is pin 1, is still connected to LED 1. But now I have pin 3, which is output B, connected to ground. So I'm going to toggle the switch to see how it behaves. So with it being a 0, it being input A being a 0, the LED is on. With it being a 1, the LED is off. That is with input B being consistently a 0. And that is parts 3. With it can be observed that this gate is behaving like a NOT gate, because since B is consistently 0, if I put a low value, I get a high, which is inverted. If I put a high value, I get a 0, which is inverted.